In Lesson 6.3, we are going to be talking about similar triangles. The concepts we're going to cover are actually something that could be applied to any type of polygon, but because our chapter is about triangles, that's where we're going to keep our focus today. Similar triangles are not congruent triangles. Congruent means they're exactly the same size and shape, and everything about them is identical. If you put one triangle on top of the other, you wouldn't be able to distinguish them apart. However, similar triangles do not have those properties. Similar triangles mean that the angle measures are the same, but the sizes of the actual triangles are different. It's kind of like that project that you did back in, I think, 6th grade when you did Super Size Me, and you did some type of object and you took its measurements and you made a much larger version of it. So you took the measurement, you multiplied every measurement in the entire thing by the same number, and you made some giant version of that candy bar wrapper or whatever it was that you did. That's kind of the idea behind similar figures. You take a smaller figure and you multiply all the sides, in this case A, B, and C, all by the same number. And over here we see KA, KB, and KC. So K, whatever that was, is what we multiplied each figure by. However, when we look at the angles themselves, angle A, angle B, and angle C, over here in our similar figure we see D, E, and F, and they have the same measures. 1 tick mark for A and D, 2 tick marks for B and E, and 3 tick marks for C and F. So the angles that correspond really are congruent. So angle D and angle F have the same measure, not A and F, sorry. A and D have the same measure, B and E have the same measure, and C and F have the same measure. Now the sides, however, are not equal. We can see we took A and we multiplied it to make it KA. But they are proportionate. So each pair of sides, if we set them up as a fraction, and you can see here the larger triangle is in red, so it's on the top. The smaller triangle is identified here in blue, and that's on the bottom. So side DE, that would be this one, it would correspond with AB right here, connecting the 1 tick mark to 2 tick marks, connecting 1 tick mark to 2 tick marks. So those correspond with each other, they make a fraction. And then EF, which connects 2 and 3 tick marks, would correspond with BC, connecting 2 and 3 tick marks. They're going to make a fraction. And then FD, connecting 3 tick marks back to 1, and CA, connecting 3 tick marks back to 1. That's going to make that fraction. No matter which of these we divide, we're going to end up with K. K is our scale factor. A similarity statement uses that one wavy line right up here. You can see triangle ABC is similar to triangle DEF. So there's no equal sign underneath it like congruent because they're not equal. It's just the wavy line over the top. So let's move into a couple of examples or pieces of information that we should be able to write or identify. You are given that triangle CAT is similar to triangle DOG. Give a similarity statement. So our similarity statement will be triangle CAT is similar to triangle DOG. Now because we have listed them in this order, we have set ourselves up to corresponding angles. So angle C, which is first, will be congruent to angle D. Now remember the angles actually are the same measure. And angle A, which we put second, would be congruent to angle O, which we put second. And lastly, angle T would be congruent to angle G, because T and G are each the last angle that is stated in our similarity statement. And then it asks us to write the ratios of the corresponding sides. So let's take a look at triangle CAT. One of those sides would be the first two letters, CA. So CA. And that's going to correspond to the first two letters here, DO. And proportionality statements are equals. Okay. Then another side of CAT would be AT. AT. And that's going to correspond with the last two letters over here, OG. And then the last side would be CT, the first and last. And that's going to correspond with DG, the first and last. Now we don't know what these all equal. Whatever it is would be a scale factor, but I do want you to make sure to notice I kept the same triangle on the top the whole time and the same triangle on the bottom. Every top of my fraction was from triangle cat, and every bottom of my fraction was from triangle dog. If two polygons are similar, then the ratios of the lengths of their sides is called the scale factor. So when you divide each of those, your answer would be the scale factor. So then we have a diagram, and it asks us to determine the scale factor for these two triangles, and it tells us that triangle KML is similar to triangle RPQ. So I can see on here several different lengths, and then on this triangle some of them didn't turn out so great, so I'm going to be able to, I want to focus on PQ since I can clearly see that that's 18. So PQ is the last two letters, so I want to use the last two letters over here, so that would be ML. So this length of PQ is going to correspond to this length of ML. So to find the scale factor, I'm going to place the larger number on the top, so this is the bigger triangle, so I know that will be larger, and then the length of ML on the bottom, and then we can simplify that. Those each divide by 3, so that would be 6/5, or if you want to use a decimal, that would be 1.2, so that would be our scale factor. The use of those proportionality statements will allow us to find missing values, and I'm going to be honest and tell you this is one of the lessons that students tend to struggle with quite a bit. So I want you to make sure to listen carefully and watch through each of the steps as I set up our fractions. We have this triangle over here, triangle ABC, in which we have all three lengths, 6, 7, and 8. And then we have triangle DEF, and we have one length, and that's 4. But I do not know EF, that's X, and DF is marked as Y. And we need to solve for both X and Y. So what we want to start with is the fact that DE is the only side we know from this triangle. So I want to identify DE up here in the similarity statement. DE is the first two letters, so it will correspond with the first two letters from the other triangle, and that would be AB. So here's AB, so 6. So 4 and 6 are going to correspond. I like to put the larger triangle on the top, so I'm going to say 6/4 equals. Now, sometimes I actually write out which triangle I put on the top. So 6 was from ABC, and 4 was from DEF. That helps me to make sure I set up my second fraction using that same format. So now we want to solve for X. X is on EF. So if I look up here, E and F are the last two letters. So from the other triangle, B and C are the last two letters. So X is going to correspond with B, C, since their letters are in corresponding position. Now I put triangle ABC on the top, so I need to have 7 on the top, and then EF will go on the bottom. And this is why we did the lesson about solving proportions as a review, because now we'll need to solve the proportion that's been created by our similar triangles. So we would have 6 times X as one of our cross products, and 4 times 7 as the other. So we have 6X equals 28. And we're going to divide by 6. And it's okay that our numbers don't divide evenly. We are not going to be worried about that. It is okay to have decimal values here, or if you want to leave them as a fraction, you can. This one turns out to be 4.6 repeating, or you could say 4 2/3. Either way would be just fine. But we have found the value of X using that proportion. Now we still needed to find the value of Y. So I'm going to go back to my original scale factor of 6/4 equals. Now Y is the DF side, so first and last letter. So from triangle ABC, the first and last letters would be A and C. So looking at that triangle, the length of AC is the 8. So I need to set my ABC triangle on the top, just like we did here in this fraction. So 8/Y. And then we'll use our cross products once again. So 6 times Y will equal 4 times 8. So that gives us 6Y equals 32. We're going to divide by 6, and again, it doesn't matter that we're going to get a decimal value, or if you want to leave it as a fractional value, you can. We get 5.3 repeating, or 5 1/3. And we have found the value of Y. The next question says, in the diagram, triangle ABC, let's identify that real quickly, ABC, oh that's the big triangle, is similar to triangle ADE, which would be this one that I just colored in. Then it asks us to find the length of EC, so this is what we want to find right there. All right, so we have, I like the bigger triangle on the top, so that would be ABC over ADE. Now what I do want you to notice is EC is not an entire length of the triangle. The side that EC is on is a part of this whole length of AC. So I need to identify that whole length first. So let's set it up and see what we can figure out. What we want is AC, so that would be the first and last letters, so AE is what that would correspond with, so AE would be this 5 right here. What I do know about triangle AB is this other side, way up here, from A to B, this whole length, I would need to add together 4 and 2 to get 6 centimeters. So I know AB, that's the first two letters. So the first two letters of the other triangle would be AD, which would be this distance right here of 4. So I would have 6 over 4 equals. Now, in this that I was looking for AB, that's my X, and what I have is AE, which is 5. Make sure you're using the sides that we marked as what we needed. That's why I underline and make those little dots, so I can make sure I'm using the correct pair of sides together. Then we'll use our cross products. So 4 times x is going to equal 6 times 5. So 4x equals 30. And then we are going to divide by 4. And we get a nice decimal this time. It's 7.5. Now that's not our final answer, because 7.5 is the entire length of AC. So AC is 7.5. But the question asked for only EC. So the whole distance is 7.5, and from A to E we know is 5. So how are we going to do that? We're going to subtract the 5, and we find out that EC is 2.5 centimeters. And if there's a unit there, we want to go ahead and include it in our answer. Since these were in centimeters, we need to include centimeters in our answer. All right, in this diagram we have that triangle SAM is similar to triangle TRI, and it says the lengths, we want to find the lengths of SM and TR. So let's take a look at what we have. In the first triangle we have SA and AM. In the second triangle we have TI and RI. So what I want to look for is one where I know the lengths in each of the triangles. So if I look at SA, that's the first two letters, that would be TR. That'd be this side, and I don't have that, so that's not going to give me a good starting ratio or proportion. So then let's check AM. AM is the last two letters, so RI would be the last two letters. Oh, and that one is labeled. So we want to use these two as the setup for our original proportion. So I'm going to put SAM and TRI, because I like the bigger triangle on the top. So AM is 15 and RI is 10. So there we have our original proportion. Now we can find out anything else we need. So we're supposed to find SM, it tells us. So SM is here. Let's mark that with an X, since that's usually the first variable we use. SM is, let me do that real quickly, underline the things we knew. SM is first and last, so it's going to correspond with TI. TI is 8. So SAM on top, and then the TRI on the bottom, so that's going to be our 8. Then we'll use our cross products, so 10 times X will equal 15 times 8. So 10X equals, let's see, 120. Then we'll divide by our 10, and X equals 12. We don't have a unit this time, so we're just going to say X is 12. Now we're going to use that same beginning proportion of 15 over 10 in order to find TR. TR is located here. It's the first two letters of the statement, so we want the first two letters of the statement, which would be SA. SA is 9. So we used the SAM triangle on the top, so 9 on the top. We can label that with a Y, I guess. That's usually the second variable we use. And then we'll use our cross products. So 15 times Y will equal 10 times 9. So 15Y equals 90. So Y will equal 6. And there we have our value for Y. Now, each of these can also be used in real-world application type of questions as well. So George wants to measure the height of a flagpole. Now, obviously, that would be fairly difficult to do. Most flagpoles are pretty tall. So he is 6 feet tall, and his shadow is 10 feet. At the same time, the shadow of the flagpole is 85 feet long. How tall is the flagpole? So we have two similar triangles here. Here's the yellow line that's representing the rays of the sun. This down here is representing the shadow. So George, who's 6 feet tall, is creating a 10-foot shadow. So here's George's triangle. Maybe shade it in just a little bit so you can see the triangle that represents George. And then we have the larger triangle that uses the flagpole, the ground, and again, that sunshine ray. And the flagpole creates this shadow that's 85 feet long. So what we know in each case is the shadow. So we're going to use the shadow to set up our ratio. So we have 85 feet from the flagpole and 10 feet from George. Now remember, I like to do the larger thing on the top. So for me, I'm going to be putting the flagpole in the top of my fractions and George's information in the bottom of my fractions. So what else we have is the fact that George is 6 feet tall. That's going to go in the bottom of our fraction, but we don't know the height of the flagpole, and that's what we're looking for. So we're going to use an X since those would correspond. They're each the other legs of that right triangle. So we'll use our cross products. So 10 times X will have the same value as 85 times 6. So 10X equals, and I don't know 85 times 6 off the top of my head, 510. Then we'll divide by 10 and we get X to be 51. The question is, how tall is the flagpole? And it's a word problem, so we want to use a word answer. So we'll say the flagpole is 51, and these are feet tall. And there we would have our answer, of course, in a word form, since it is a word question. All right, then we get to one that's pretty tricky. It's actually kind of neat, in my opinion, because, you know, I am a math nerd. That when you have a right triangle and you draw in the altitude from M to side that is the hypotenuse, so the right angle to the hypotenuse, you actually form three similar triangles. So you've got the large triangle, JLM, and then you have this really little one of LKM, but you have yet another right triangle of JKM, and all three of those end up being similar to one another. This asks us to look at JML, so that's the big triangle, and MKL. So that would be this, if I can get it to color, this teeny tiny one right here. It says to find the value of X. So X is on the little teeny triangle. So I'm going to be doing triangle JML over MKL, because I like to do mine as large over small. So the only other side I have from the small triangle is LM. So LM, I'm talking small triangle, so that's these two, first and last. That corresponds with JL from the other one, JL. We can see JL is a hypotenuse, and if we look at this little triangle, there's the 90-degree angle. LM is the hypotenuse as well. So hypotenuse over hypotenuse. And then we know we need X. X is KM. So the first two letters that will correspond with JM. JM right here would be 12. So 12 is going to go on the top, and X will go on the bottom. Then we can use our cross products to solve our proportion. So we'll be doing 13 times X as equal to 5 times 12. So 13X will equal 60, And we're going to divide that, and I know I'm going to get a decimal. Oh, I get a crazy decimal. So instead of saying equals, because it does not truncate or terminate, it fills up the entire calculator screen. So we'll approximate that to be 4.6. I don't have any units to label, so we're just going to say x is approximately 4.6. These questions do get a little tricky as you set up your proportions, so I want to make sure that you think about setting up which triangle you want on top and which one you want on the bottom, and make sure you're consistent with that. And then utilize the similarity statement that's there to figure out which sides go together. And if there's not a similarity statement already there, then write one. That way you can use your underlinings, your dots, whatever it is you need to use to help you set up this fraction correctly. Usually the trouble is not over here in the solving. Usually the trouble students have is right here in the setup. So make sure to be very careful about that. Pay careful attention to what you're doing. If you have any questions at all, please don't hesitate to get a hold of me. Have a great day.